So, okay, yesterday we discussed the relation between roots and coefficients of polynomial, right? And in this problem, have you solved this quadratic equation? Yes. Solve this. If you have solved a quadratic equation, you will get values of alpha, and from that you will get values of beta. So, solve the equation. 8x cube minus 36x square plus 46x minus 15 is equal to 0. So given that the roots are in arithmetic progression, so you know what is arithmetic progression? So what is given polynomial? Given polynomial f of x is equal to 8x cube minus 36x square plus 46x minus 50, and we want to solve it. So we can write it in standard form: 8 into x cube minus 36 by 8 plus 46 by 8x minus 15 by 8. Correct? So we can further simplify it. So what is it? 8 x cube minus 9 by 2x square plus 23 by 4x. Correct? You check whether I am writing correctly. Is it correct? Yes. So let alpha, beta, gamma be roots of f of x. Suppose these are roots. Then by relation between roots and coefficients, what is alpha plus beta plus gamma? Sum of roots is what is sum of roots?
Minus of coefficient of x square.
So but coefficient of x square is minus 9 by 2. Its minus means 9 by 2. Correct? Second, what is the sum of product of two roots? Alpha beta plus beta gamma plus alpha gamma, right? Product of two roots and their sum, and it is
23 by 4.
coefficient of x. Third, what is product of roots? Alpha, beta and gamma is minus of constant term, but constant term is minus 15 by 8. Its negative means 15 by 8. This is what we have. These three conditions. And fourth condition, roots are in AP.
Hello.
Yes.
Hello.
So roots are in AP. So roots are in arithmetic progression means what? When we say that two numbers are in arithmetic progression, Roots are in AP, that is alpha, beta, gamma are in progression, arithmetic progression. So what is the relation between alpha, beta, gamma?
Beta minus alpha is equal to gamma minus beta.
So our three numbers A, B, C are in arithmetic progression means what? Key middle term is
Alpha
in,
plus beta.
right. So B is equal to A plus C by 2, right? Am I right? If these three numbers
Yeah.
are, so mean, middle term is mean of the two adjacent terms. So therefore, alpha plus gamma upon 2 is equal to beta, or alpha plus gamma is equal to 2 beta. This is what additional information given. So we are writing very systematically so that there is no confusion. Now from 1, alpha plus beta plus gamma is equal to 9 by 2, and uh, alpha plus gamma is 2 beta, and by 4, 2 beta is equal to alpha plus gamma. Therefore, what we get, alpha plus gamma is equal to 2 beta. So 2 beta plus beta is equal to 9 by 2. Am I right? And therefore, what is beta? So what is beta?
3 by 2.
Right.
3 by
So
2.
3 by 2. Very good. So we got one root. Now we want to find remaining two roots. Right. So okay, now so therefore put beta is equal to 3 by 2 in 1. So what we get, right, if you put beta is equal to 3 by 2 in 1, then alpha plus gamma, which is plus 3 by 2 is 9 by 2, and therefore alpha plus gamma is equal to alpha plus gamma is equal to what? 9 by 2 minus 3 by 2, so 6 by 2, so it is 3.
3.
Let us call it as expression 5. And also from which equation? Third equation. From third equation, if you substitute value of beta, so from third equation, alpha, beta, gamma is equal to 15 by 8, and therefore if you substitute value of beta, so alpha, gamma 3 by 2 is equal to 15 by 8. That means alpha gamma is equals to
5 by 4.
5 by 4. Very
5
good.
by 4.
Right. Alpha gamma is 5 by 4. So that what we get from this, and which from this gamma is equal to 5 upon 4 alpha. Gamma is 5 upon 4 alpha. Now remember that can we divide by alpha? Is it allowed? Is it allowed to divide by alpha? This is a basic question. Very basic question. What do you think? Is it allowed to divide? When it is not allowed to divide? Do you understand? When it is not allowed to divide by a number.
When alpha is
When
equal to
it
0.
equals to 0.
Alpha is equal
Yes,
to
sir,
0.
we can divide by alpha.
And we are sure that roots are non-zero. If roots were 0, then product will be 0. You understand? Note that roots are non-zero. Correct? Do you understand this? Roots are non-zero, we are sure. If one of the roots is 0, if at all one of the root is 0, then product will be 0, but product is non-zero. That is why the equation it is clear. So it is allowed to divide, right? So put expression 6 in 5. What is 5? Alpha plus gamma is equal to 3. So alpha plus gamma is equal to 3. But what is value of gamma? 5 by 4 alpha. So alpha plus 5 by 4 alpha is equal to 3. That means 4 alpha square plus 5 is equal to 12 alpha, or 4 alpha square minus 12 alpha plus 5 is equal to 0. So now this is a quadratic equation in alpha. So solve this. Solving 7 for alpha, what we get? Right, so this is a quadratic in alpha, and solve this for alpha. So we get the two values of alpha is can you tell me directly, or 5 by 2, 1 by 2.
4
You
by
check.
3. No, sir, it's 5 by 2 and 1 by 2.
Correct, right?
Yes.
5 by 2 and 1 by 2. So these are the two values of alpha. Now let us check. Now if alpha is equal to 5 by 2, then what is beta? Or what is gamma? Beta already known, right? And alpha plus gamma is equal to 3. That means gamma is equal to 3 minus 5 by 2. What is it? 1 by 2. Correct? Do you understand? If alpha is equal to 1 by 2, then we'll get gamma is equal to 5 by 2. One and the same thing. And therefore, unlike to the yesterday's problem, both of the values of alpha are acceptable in this case. Correct? Yes. What I am saying, is it clear?
Yes, sir.
Right. Therefore, here the two values of alpha are actually the both of the roots. One is alpha and another is ultimately gamma. Right. Whichever is alpha, whichever is gamma, that doesn't matter. Because all these expressions are symmetric equations in alpha and beta and gamma. Symmetric. So what is the meaning of symmetric? So therefore roots are, what are the roots? 1 by 2. What is beta? It is 3 by 2. And what is gamma? 5 by 2. Or if you call alpha as 5 by 2, then beta is, gamma is 1 by 2. So same thing. These are the roots. Yes. Any doubt in this? Is it clear? See, while finding roots, we have to just play with these four equations, four expressions. This the three for relations between roots and coefficients, and fourth is given information, additional information. We have to just play with these four things and solve this for alpha, beta, gamma. Yes, is it clear?
Yes, sir.
Okay, fine. So so okay, solve the equations. Solve the equation 4x cube minus 49 x plus 60 is equal to 0. So given that two of its roots differ by 1, differ by 1. So this is additional information, and therefore write down 4 expressions directly. So given fx is equal to 4x cube minus 49x plus 60. This I can write in, I will the leading coefficient I can separate it out, so that x cube minus 49 by 4x plus 60 by 4. Leading coefficient should be 1, and then we compare the let alpha, beta, gamma be roots of f, then alpha plus beta plus gamma. What is it?
0.
0, because coefficient of x square is 0. Alpha beta plus beta gamma plus alpha gamma is coefficient of x.
Minus 49.
Right, minus 49 by 4. Product of roots is minus constant term 60.
15 minus 15.
So I can divide by 4, right? So what is it?
Minus 15.
Minus 15, right? And fourth condition, what is given condition?
Alpha minus beta is equal to 1.
1.
Difference of two roots is 1. Two roots differ by 1, that means suppose alpha minus beta difference is 1, or alpha is equal to 1 plus beta, the same thing. Whichever is first root and whichever is second, that doesn't matter actually in this case. So these are the 4 things known. Now from this we want to solve, right? So substitute this fourth in 1. That is the first step, because that is simple to reduce. So substitute 4 in 1. So what we get, so alpha plus beta plus gamma is equal to 0. That means alpha is 1 plus beta. So 1 plus 2 beta plus gamma is equal to 0, or 2 beta plus gamma is equal to minus 1. Am I right?
Yes, sir.
Yes, sir.
Right. Okay, then okay, now substitute second expression. What is second expression? Second expression is what is second expression? Alpha beta plus beta gamma plus alpha gamma. What is it? Minus
49 by
4.
4.
So here what we, so substitute
Alpha is equal to 1 plus beta.
Alpha is equal to 1 plus beta. Then 1 plus beta into beta plus okay, so beta gamma plus 1 plus beta gamma is equal to minus 49 by 4. So do 1 by 1. So see what happens. Beta plus beta square plus beta gamma plus beta gamma is equal to minus 49 by 4. Let us simplify this. Beta square plus 2 beta gamma plus beta plus gamma, right, is equal to minus 49 by 4. Now can we eliminate gamma so that we'll get expression in beta or quadratic equation for beta? Can you eliminate? Here you can eliminate gamma, right?
Yes.
So what is gamma?
Gamma is equals to minus 1 plus 2 beta.
Gamma is minus 1 minus 2 beta, right?
Yes.
From 5, gamma is minus 1 minus 2 beta, right? So let us call this as 6. So put in 6. So what we get? Beta square plus 2 beta minus 1 minus 2 beta plus beta minus 1 minus 2 beta is equal to minus 49 by 4. And then simplify this. So beta square minus 2 beta minus 4 beta square, and here minus beta minus 1 is equal to minus 49 by 4. You check the calculation if I am wrong. Minus 3 beta square, correct? Minus 3 beta, okay, minus 1 plus 49 by 9 is equal to 0.
49 by 4.
What?
49 by 4, sir, not 49 by
Sir, it
9.
should be 49 by 4.
49 by 4, right? Okay, so minus 3 beta square minus 3 beta, so minus 4 plus 49, so 45, right?
4.
Right. Now simplify this so that we can find roots. This is a quadratic, so minus 12 beta square minus 12 beta plus 45 is equal to 0. And what is common which we can what is a common factor? 3, right? Plus, correct? Okay, you check whether it is correct final expression.
So
Correct?
we can again multiply by minus sign.
Yes. That is what last expression I have written.
Yes.
Now what are the
Sir,
roots? Yes.
Sir,
can you scroll up? Yes, sir. In the first line, where is that 2 beta? The class 2 beta.
Okay, let me check. Okay. Sixth expression is correct. Beta square plus 2 beta gamma plus beta
Yes.
plus gamma. Now,
Yes,
uh,
sir.
what I am fifth, is fifth correct? 2 beta plus gamma is minus 1. Is it correct?
Yes.
Yes, sir.
Yes, sir.
So the
And
roots are 3 by 2 and minus 5 by 2.
okay, okay. Final expression is correct. First of all, is final
Yes.
expression correct?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
now solving for beta. What are the values of beta?
3 by 2 and minus 5 by 2.
3 by 2 and minus 5 by 2. Okay, very good. Are these correct roots?
Yes, sir.
Right. Correct. Roots are correct, then no problem. So, if beta is 3 by 2, then can you calculate another root? Can you find another root? Is there any relation between beta?
Then gamma equal to minus 4.
2 beta plus gamma is minus 1. So, that means 2 into 3 by 2 plus gamma is minus 1. And therefore, gamma is minus 1 minus 3. So, minus 4. Right?
Sir, alpha is equal to 5 by 2.
Now there is a relation between alpha, beta, gamma, or you directly calculate value of alpha from this first expression or last expression, the third expression. Right? You know now beta and gamma, calculate alpha.
Yes, sir. It's 5 by 2.
5
Is
by 2, sir.
5 by 2. But I think here beta is 3 by 2 and 5 by 2. You check it or no? Product of roots. Is correct? Anyway. Now what we get? We get this value of alpha is 5 by 2 from this. Now check whether what we found here, alpha is 5 by 2, beta is 3 by 2, gamma is minus 4. Right? Is this acceptable? Are these acceptable? Acceptable means what? First of all, what is alpha, beta, gamma? Alpha, beta, gamma is minus 15. Is it correct?
Yes, sir.
Yes, sir.
Yeah.
Okay, fine. 5 by 2, 3 by 2 minus. Now if beta is equal to minus 5 by 2, is it acceptable?
No, sir.
So no, sir. Second one is not acceptable.
No,
No,
sir.
sir.
Not acceptable. Why you check the substitute these values in above expression, you will find that okay, this is not acceptable, and therefore roots are this. Correct? Okay, now find a cubic polynomial which vanishes at x is equal to 2 and minus 1 and has value minus 20 at minus 2 and minus 14 at 1. What is the question? We want to find a polynomial of degree 3 and what is given information. So what is our
f
one?
of minus 2 is equal to minus 20.
F of minus 2 is minus 20 and f of 1 is minus 14 and at 2 and minus 1 values are 0. Right. Want to find f of x equal to ax cube plus bx square cubic. We want degree 3 polynomial, right? So cx plus d such that f of it vanishes at 2 means f of 2 is 0, f of minus 1 is 0 and value at minus 2 is minus 20 and value of function at 1 is minus 40. So this information is given. Fine. Right. So and therefore what are the unknowns in the given in this function f? What are the unknowns?
A, B, C.
A, B, C, D, right? Coefficients. Once you get coefficients, the polynomial is completely determined. So only thing is how to find these unknowns. Once unknowns are known, we know everything about the polynomial, right? But these four things are given. This is our data, right? From this data set, we want to evaluate this. So f of 2 is equal to 0. That means what is f of 2?
8
8a
A plus 4B plus 2C plus D.
plus d, that should be 0. Then f of minus 1 is also 0. So minus a plus b minus c plus d is equal to 0. F of minus 2 is minus 20. So minus 8a plus 4b minus 2c plus d is equal to minus 20. And f of 1 is minus 14. So a plus b plus c plus d is equal to minus 14. So we have 4 equations in 4 unknowns. So this is a system of of 4 equations in 4 unknowns. Okay, is there any way to simplify this system, right? So that you can find out the values of, for example, if you look at first and third, from that you can eliminate 2 unknowns, right? Let
A,
us
B, C.
1, 2, 3, 4. So
Similarly
1,
with second and fourth too, sir.
Sir,
Adding
adding
both.
second and fourth, we can eliminate A and C.
right? First of all, look
And
at first and third. If you add first and second, what we get? First and third, not second. First and third. Add first and second. Third. First
8B plus 2D is equal to minus 20.
8b plus 2d is equal to minus 20. Right. And second and fourth. If we add second and fourth, what we'll get?
2b plus 2d is equal to minus 14.
Right. Second plus fourth, what we'll get? 2b plus
2b
2
plus 2d.
minus 14. Right. Now, if you solve these two linear equations in terms, you get values of b and d. Correct?
Yes, sir.
This is
Minus 1 and 6, sir.
what are values of b and b is equal to?
B is minus 1 and D is minus 6.
Very good. So immediately you get values of b and d. Similarly, how to get values of and once you get values of b and d, substitute any of the two equations and calculate values of a and c. Right? Understand the next part. Or what alternatively you can do? Alternatively, you can do it as 1 minus 3 and 2 minus 4 and see what happens. 1 minus 3. This b and d term get cancelled. So 16a plus 4c, right? Or you directly substitute values of b and d. You will get expression in terms of a and c. So 20 and 2 minus 4. 2 minus 4. So or 4 minus 2 or 2 minus 4. Same thing. So minus 2a.
Minus 2c is equal to 14.
Minus 2a minus 2c is equal to 14. So these are two equations in a and c, and then get the values of a and c. So a is equal to and c is equal to. Yes. What are the values of a and c now?
A equal to 17 by 6.
And c is equal to
Minus 59 upon 6.
minus 59 upon 6. C, value of c.
Yes, sir, from the value of A.
Okay, you check these values. Minus 59 upon.
So I am getting values as A equals to 4 and C equals to minus 11.
Yes, sir. Same.
Yes, sir, same.
Right.
Yes.
A equal to 4 and C equal to.
A is equal to 4, C is equal to minus 11. Correct. These are correct values. A is equal to 4, C is equal to minus 11. So this is just part of calculation, not difficult. So fine. So these are the values. Therefore, what is our polynomial? Therefore, f of x is equal to ax cube plus bx square plus cx plus d, which is 4x cube minus x square minus 11x minus 6. This is a polynomial satisfied. And this is very interesting problem because so somebody was asking what is the use of polynomials, right? I will tell you how this problem is very interesting. What was given? You were given some values x and y. What was the given data? If y is equal to fx, this is my function, suppose. What was given data? At x is equal to 2 minus 1 and minus 2 and 1. Here 0, here minus 20 and here minus 40. This data is given. Do you understand this was given? Yes.
Yes, sir.
What is my y? Y is value of function at x, or y is a value of polynomial at x. Then this data was given. Key value at 2 is 0, value at minus 1 is 0, value at minus 2 is minus 20 and 1. So this data is given. From that we have found the polynomial function using this data. Now what is use of, can you predict the value at 100? Is it easy to predict now?
Yes.
Yes, sir.
X is equal to 100. Right, so this is called as a interpolation.
Yes, sir.
Yes.
This is after we knew that it was that the function was a polynomial, even more specifically a cubic polynomial. After that, we were able to interpolate.
Right. So sometimes, see, there are lots of problems. For example, weather forecasting, uh, or the path of a satellite, path of a planet. There are lots of problems. Economics, trend of economic situation. There are lots of problems in real life, or any pandemic, right, where situation will go. So you have some data, discrete data, some finite data. Here we have data for 4 points. Data is known for 4 points, right? Suppose you know data for 100 points and suppose 1000 points. In general, data might be very huge, but from that information you can find a trend of that data. That is approximation, and there is no technique exists in universe at all. There is a perfect technique which will give you exact predictions, right? That's why many times weather forecasting fails. If tomorrow is raining, may not rain, right? So there is approximations, and from the data we can approximate polynomials, or polynomial is the simplest way, but that is not more accurate, right? There are some other techniques to given data, how to find a function, basically how to find a function which satisfies this data, and trend is similar to this data set, and from that you can predict. But this is one of the techniques, not always useful this technique, but from finite data you can have a function, and from that you can predict,
Yes, sir.
right?
But sir, like in this case, we knew that the nature of the graph was that of a cubic polynomial. So, is there a way that we can know how the nature of the graph that we want to predict is?
See, from these 4 points or this finite data, it is not possible to predict what is a polynomial or exponential or combination of trigonometric and polynomials. So it is not easy, but uh, to increase your accuracy, you can get a function which is more general, like uh, exponential, trigonometric, and polynomial, their combination, right? But if you want to find rough approximation, you can find polynomials. But here we are assuming we want to find polynomial approximation. Right, it depends on what is your problem.
Sir?
And one more observation is what basically this does, you are given data, you are given values at what points, you are assuming values at -1 and -2, 1 and 2. These 4 points were given, and at 2 value is 0, at 1 value is -14, right? At okay, at 1 value is -14, at -2 value is -20, not minus, at 1 -1 value is 0. So Remember that our function passes through these points, these red points, right? Because this is given data. Now, and I want to find polynomial. So what is naturally I am going to do? I will try to find a polynomial which passes through these points. This is my actually the expectation. I will try to find a polynomial which passes through these 4 points. But what happens in between? In between there may be error, and therefore if you take data for in between point for 0, it may be here, not passing through this graph. There is error. To avoid error, if your data is used, that means if you know values at 1.2, 1.3, then 3.2, 3 by 2. So if your data is large, and then your accuracy is more. Correct. Is it clear? This is a rough idea what I am saying, but the things are used in that way. Okay, how do we need polynomials and all these functions, their graphs and their properties?
Yes, sir. So
Right.
up to now, we
Sir,
discussed
Yes.
the degree 3 or 4 polynomials that we can predict if the conditions are given. The same technique we can use for the other degree polynomials, means higher degree polynomials.
So what is one important thing here? We have degree 3 polynomial, there are 4 questions, right? And how many data points are given? 4 points. And therefore we get 4 equations. And therefore, if you have 4 equations, linear equations in 4 variables, then it is easy to solve. Correct.
Yes.
If you have, if you want to find 4 degree polynomial, right? If your degree of polynomial is more, then that will give you more accuracy. Right. And how to calculate accuracy, then the definition what you learn in calculus. Given epsilon, there exists k and so on. That error, epsilon is a error, and how to minimize the error. And then when there are researchers or scientists using these techniques to solve some real life problems, and they are trying to reduce the error. And what is error? Something minus something is less than epsilon. They are trying to reduce the error. Right. If you want to reduce the error less than epsilon, then you have to choose some data greater than that or something after some k and so on. So these ideas are used. So this is just approximation so that you can predict the what happens for other points. But if we want to find 4 degree polynomial, then there will be how many unknowns? 5 unknowns, right? And if there are 5 unknowns, you need to have 4 points, 5 points, so that your equation can be solved easily.
Yeah, means according to the degree we solve that equation.
At this point, it is easy to have 4 points and 4 unknowns, so that equations you can easily solve. But in general, there are techniques. Whatever is the situation, there are techniques available. You can find approximate solutions. And you can understand. The only point is how these ideas are used. Right. So each and everything has lots of applications. Right now, it is not easy to see directly, but remember, if you read the books, then you can understand in every field of science or every field of life, in geography, geology, whatever field you select. Correct?
Yes, sir.
Fine. Anyway, so okay, we'll take a break of 5 minutes, 5 or 10 minutes, and then we'll start again. Right? Then we'll start with, so for polynomials, I think this much is sufficient at this point. So we'll start with our new topic, complex numbers, which is our last chapter. We'll start in next lecture, means after 10 minutes. Right. And after that, I will share with you practical sets, question sets, and if we get some time in next week, then we'll try to solve the questions or problem sets, practical questions, so that you will understand all the concepts will be revised again. That will be helpful you to for final exam, right?
Sir,
Yes.
sir, can you upload the lectures of polynomial?
Yeah, I have uploaded till last lecture, right?
Okay, sir. On
Uh,
stream or in chat box?
Stream.
Okay, sir.
You can go through the link and then you can see the lectures, right? And
Okay,
you
sir.
try to solve the problems which are there in Acharya sir's book. On Acharya sir's website, book is available, a book written for university, and in that polynomial chapter, you try to solve the at least those problems. I will share you more problems also.
And sir,
Yes.
also upload the notes on the class materials.
Past material means?
Means our lecture notes.
हा. Teams वरती आहेत ना.
But sir, it is not visible till 12th December.
12th December. आता दिसत असतील, मी काल केलंय ना अपलोड.
Okay, sir.
ठीक आहे. Okay, so we'll take break of 5 or 10 minutes, 5 minutes, and we'll again start. Correct?